Good morning, everyone, and welcome to today's webinar. Today we're going to be talking to you about heat networks and geothermal energy. We're just kicking off now at 10 o'clock. I'm expecting we're going to get a few more people joining us over the next few minutes. I'll just share the agenda with you briefly. Today we're joined by a fantastic lineup of speakers. To kick us off, we've got Dr Kieran Mullan MP, who was recently asked by the Prime Minister Rishi Sunak to undertake a review into deep geothermal heat and energy options for the UK. The report was published in June, so we're really delighted to have him join us to talk about the findings today. We then have Andrew Cripps, who's Technical Director in the Heat Networks team at Triple Point Investment Management. He joined in 2021 from AECOM and has over 30 years experience in engineering consultancy, specifically relating to heat networks, sustainability, energy and the built environment. We're then joined by Rick Evans, who's the Commercial Director for GT Energy. He's got significant experience delivering and working on energy projects around the world, and brings that specifically into the UK geothermal sector. GT Energy have a number of active geothermal developments across the country and a pipeline of many more to come in the future. We're then going to be joined by Ralph, who's worked as a head of the environment department in the community of Pullack. It's a city in the county of Munich in Germany. His team has been developing a geothermal project, which includes a district heating network. So really excited to hear from his experiences and how we can bring that into the UK market. We're then joined by Gus Grand, who's the Chief Executive from Eden Geothermal. Gus has been working on the geothermal project since 2012, and she's been at the Eden project since 2001. She's previously been the head of policy at Eden and was developing their sustainability and science programme. Finally, we're joined by Eloise Travis, who's the programme manager. She is working. She's worked in the public and private sector across the UK and overseas. And she is leading the construction and commercialisation of the UK's first deep geothermal district heating network at Langgarth Garden Village. We'll have time today to take questions from all of you, and I'll just talk you through actually how to submit your questions. So you'll see on your screen we're using a slightly different form of Teams than many of you might be used to. So today we're using the Q&A function. At the top of your screen you'll see 2 speech bubbles. If you use those speech bubbles you can type in your question. The question will come through to us and we will publish it. If you like a question that's there and would like to boost that question up, if you click the thumbs up sign, you will be able to do that, and we'll answer as many of the questions as we can today. We expect we're going to get quite a lot of them, so we might not get through absolutely everything, but we will take them away and try and share answers as soon as we can to the questions that come through. So we're here today to discuss how geothermal heat can help us address some of the challenges you can see on the screen. We have a target to try and meet 1/5 of heat demand using heat networks, and using geothermal energy as part of trying to achieve that target is a really exciting opportunity and something which we thought we wanted to explore in a bit more detail. So just a quick introduction before I hand you over to our fantastic speakers. Who are we? So I'm Samantha Shea. I'm the head of policy at GemServe. We are part of the Triple Point Heat Networks Investment Management Consortium Group, delivering the Green Heat Network Fund. I'll share a couple of links for more information about GHNF, but you'll see on screen that's the guidance document, which may be of interest to any of you looking to deploy heat networks across the UK. So I will hand over now to Kieran.
Thank you very much, and good morning, everybody. And thanks to Triple Point for inviting me along today. My name's Dr Kieran Mullan. I'm the Member of Parliament for Crewe and Nantwich, which is in the northwest in Cheshire. And this opening slide is a picture of me staring very lovingly at a deep geothermal. Well, I'm not going to say plant, a borehole, like sitting within a plant. And Triple Point thought it'd be good today to have me come along just to talk more broadly about deep geothermal and government action and politics, etc., ahead of what are really fantastic speakers that can take you through the technical side of things in more detail. And actually, one of the reasons I think it's really great to hear from me is I think very often when you have experts from a field coming along and championing it, you kind of have this thing in your mind of, well, you know, you would say that, wouldn't you? It's what you think is amazing. I'm a layperson. I knew nothing about this stuff until a couple of years ago. So you can take some reassurance from me that this stuff works. It's deliverable because I've been out there and I have a look at it and I know it works. So if you could take me on to the next slide. So this morning I'm going to talk about my background and interest, why I've got involved in deep geothermal, talk about my review that I conducted for the Prime Minister, talk about the opportunities, and as I said, try and imbue you with some confidence about the reliability and the effectiveness of this technology, and just touch on a couple of what I think are important things for you to keep in mind as part of my review. Thanks. So, as I said, I knew nothing about geothermal. I was selected to be the candidate, so not even the MP for Crewe and Nantwich in 2008. And I was literally walking the street, knocking on doors, and it'd been in the newspaper that I'd been selected. So kind of some people had an awareness of who I was. And a random person came up to me on the street and said, oh, you know, you're going to be hopefully the MP for Crewe and Nantwich? There's this thing I must tell you about, deep geothermal. It's great for Crewe. It's going to give you clean, not free, but clean, cost-effective energy for people in this area and heat in this area. You must look into it. And I'll be brutally honest, he approached me on the street randomly. I didn't know who he was, and I thought, right, you know, I'm sure that sounds great. It just sounded a little bit too good to be true, and I kind of parked it in the too good to be true box and moved on. But then I was approached by a company in December 2020 who really had a more serious discussion with me about the potential for deep geothermal. So I looked into it more seriously and found actually it isn't too good to be true, and there is real potential for it. And next slide, please. And from my perspective, I'm interested in it because as a Crewe and Nantwich MP, this is a map of what's called the Cheshire Basin, and you'll go on to learn about you know, what deep geothermal resources look like, but doesn't take a genius to see there's a boiling red hotspot, and that Crewe actually is located right in the middle of that hotspot. And so for me, a deep geothermal industry that's thriving in the UK is only going to bring benefits to my constituency, and so that's why I thought it would be good to get in there and try and support it. Next slide, please. And so as an MP, what can you do? Really fundamentally, the most important thing you can do as an MP is profile raising. You can be in the House, asking questions in the media, talking to ministers about an issue and getting them to pay attention to it. Because fundamentally, if you're a government minister and there are MPs asking you questions about it in public, on camera, you want to be able to give good answers. And so if the minister's being asked about something, then the civil service have to go away and look into it. And the first bullet. So you ask a question, stage one, you know, the first time you ask a minister a question, they just take the answer off the shelf. And then you ask the question again, it's also off the shelf. And then you ask the question again, maybe it's also off the shelf. And then you ask the question again, and then possibly, maybe the answer they give is not off the shelf. And that's been really important, me understanding that as an MP, that the civil service is not you know, stacked with geological experts. The staff isn't there to every day look at everything that's happening in all different industries. At different points in time, the civil service form an opinion on something by getting experts in, and that opinion sits there and is the opinion until something really significant causes them to go away and have a look at it again and change that opinion. So I found that, you know, you're asking the same questions, you tend to get the same answer for quite a while. So you have to keep pushing and pushing. Next slide, please. And so I was very, very lucky because I kept on pushing and wouldn't let it drop, that the Prime Minister, actually originally Prime Minister Johnson, but continued under Prime Minister Sunak, asked me to actually go away and look at it properly then. You know, Kieran, if you're so enthusiastic about it, you go and have a look at this for us and come back and present your findings. So I spent more than a year really, on a deep dive looking into deep geothermal as a technology. You've heard about Bullock and Munich. I was lucky enough to go over there and visit, and that's where that photo's from. And I spoke to geologists, industry experts, policymakers, did some surveying of industry, and commissioned some academic research into where we could potentially do this. Next slide, please. And some of my really key findings, which I'm really going to focus on Europe for that reassurance point, is that this industry is raging across Europe. It's heating 250,000 homes in Paris. Across France, there's more than 600 megawatts of heat are produced annually, and actually the government in France aims to increase the number of schemes by 40% by 2030. Munich is pouring 1 billion euros into deep geothermal up to 2035, and actually in Germany they've got 353 megawatts of heat annually, and they want to increase it by another 100 projects in that time period. So it's a successful, proven, credible industry that's raging across Europe. Next slide, please. And as touched on, this is important because the climate change challenge, particularly when it comes to heating, is enormous. So as you heard earlier, the heating challenge in homes and buildings is huge. It's 28.5 million homes, 1.9 million buildings, and the vast majority of these are heated by gas boilers, and nearly a fifth of all our emissions come from buildings, and just the heating buildings, let alone the electricity side of things. Next slide, please. And actually, talking very crudely, you're going to go on to hear in more detail, these are all the areas across the UK where we could really be motoring on deep geothermal potentially. And what I did in my review actually is, this is quite a common thing that you'll see, this map. And actually what I felt was, from a politics point of view, if you want to start getting people engaged, if you want to get MPs engaged, local councils engaged, you kind of have to move beyond just geographic sways of territory, because that's kind of that old adage that everyone's responsibility is no one's responsibility. So you actually have to make it some people's responsibility. So what I asked the Durham Energy Institute to do is to go away, next slide please, and and think about what's the actual potential in the UK, make it live, make it real. They'd already done some research on the national potential, and so actually there's enough of a deep geothermal resource in this country to meet all of the UK's heat demand for 100 years. So there's a huge resource there. The challenge with deep geothermal is matching that up. So there's no point having this amazing resource, and the technicalities of it you're going to get to hear about, in the middle of nowhere, not near to a hospital or a housing estate that can actually utilise it. So you have to match it up. So we're never going to utilise that whole theoretical resource. But let's say just a quarter of that resource is utilised. It's a huge impact. And so I asked Durham then to go further than just look at the overall resource and match that to local authority areas, because local authority areas start narrowing it down. And these were the academic researchers' outputs, really, to say that across the country, where's their demand, where's there a reliable, understood heat resource that we could actually start delivering this, and that identified these local authorities. And then alongside local authorities, you then find out who are the MPs for these local authorities, and it helps drive this agenda forward. And the other thing that we decided to do is look at, well, where does this match up to levelling up? Because whenever you want to drive forward a policy area, in this case, we're talking about climate change and going green, if you can hook it into another really important policy area, that helps get things done. So in this case, we thought looking at levelling up would be important. And actually, across these local authorities, 6 of them are in the top 10 of areas most in need of levelling up, according to the government's index for measuring that. And actually 44% of them overall are levelling up local authorities, which is 3 times the amount you would expect by chance. So it's a really great synergy. If we deliver this technology, we're going to be delivering levelling up. Next slide, please. Which then begs the obvious question. There's a huge potential. It's working really well in Europe, then why aren't we doing it in the UK? And that's probably the anxiety you might have. My understanding from the research, speaking to people in the industry, actually part of it is we've been a victim of our own success in oil and gas. So if you're in the drilling business, and this is all about drilling, in the UK you were focusing on oil and gas because it was such a strong sector for us, and the government's focus historically hasn't been on the heating challenge, it's been on renewable electricity, and we've done a great job of that as a country, but it meant that there wasn't really the energy going into deep geothermal. And importantly, historically, deep geothermal has been electricity focused. So the early adopters of this stuff were countries like Iceland, where you have very high temperatures and you can deliver electricity. So that opinion off the shelf that I talked about, that was from government looking at electricity. And actually the UK, whilst we've got some great potential opportunities for electricity in some places, it probably isn't going to be the leading edge of this technology. And so that opinion about what deep geothermal could do was based on whether or not we could do electricity, and it didn't really understand the heating. And then at the same time, Europe started ploughing money into this in terms of subsidies and insurance and other things, which just meant that there wasn't the competitive advantage. We fell behind. Next slide, please. So at a national level, what I'm going to be doing and have been doing is working with other MPs and setting up an all-party group to try and get some changes in how we do this that might advance deep geothermal. So we're looking to get a tariff for deep geothermal so that it's supported in the same way that electricity and other renewable industries are supported, helping the government understand that in difference to other types of renewable resources, they have to learn to support the industry to deal with risk, which isn't there when it comes to other types of renewables. Get that on off-the-shelf opinion changed. We're seeing it happening already. Fantastic news with Cornwall that a number of plants for electricity where we can do electricity in Cornwall have been given government support. And as I said, setting up that cross-party set of MPs. Next slide, please. And the main message I want to get across that I've learned is stakeholder engagement is really key for this technology. I'm going to talk about the F word, which is fracking. If you start talking about drilling in the ground, the first thing people think you're talking about is fracking. And actually, it's not fracking, it's something like fracking. And there are some really great ways that you can make those arguments. That picture of me there is outside that deep geothermal plant you mentioned. And the reason why I've chosen that picture is in the background. That building in the background is a school, and the space in between was a park. And so this is really safe, welcomed by communities, and doesn't have to cause any issues. That they're building these things right next to schools, and there are some great people to help you make that argument. Fantastic to have the Eden Geothermal project here with you today. You know, the public understand that Eden is a clean green project in this country, and they're doing deep geothermal. They've opened one of the first deep geothermal heat plants in something like 40-50 years. Greenpeace are behind it, and this is no more complicated than the Roman baths. This is the technology that we're focusing on. You can understand why. And actually engaging with local government, engaging with MPs means that when you go to engage with the media, the tricky audience, you've got that support, you've got those voices helping you. And as I said, I would really encourage you to talk to the Eden Project if you move ahead with deep geothermal, because they really know how to do this. They've done it. Next slide, please. And actually, me personally, you know, what I want to do is just help push it at a national and local level. So if you're looking at developing a project, I'm happy to talk to your local MP about it, invite them along to the All Party group that we're forming, discuss with your media teams and comms teams based on my experience of doing the media for my report, how I engage with local media, even talk to your council as well. Because as I said, a burgeoning deep geothermal industry in this country is going to be a great thing for my constituency. And actually, I happen to think it's a really great thing for the country as a whole. We've got to tackle this decarbonisation challenge, and we need to get all the possible ways of doing it up and firing. And so I think it'd be great if we can get deep geothermal as even more of the mix. So I hope that's given you kind of a bit of context, and you're going to go on to hear the understanding of the technical side of some of this stuff. And thank you for listening.
Thank you very much, Kieran. We're now handing over to Andrew Cripps, who will talk a bit more about why there's heat under our feet and how we can potentially access it. A lot of the information that we've got with us today and Andrew's going to be presenting was provided by the British Geological Survey, and we've provided some links to some relevant documentation. Andrew, over to you.
Thanks, Sam. Yes, as Sam said, we might have had this section presented by the BGS, but unfortunately they weren't able to attend. So I'm going to do my best to explain it. If you have any proper geological questions, we might need to pass them on to the BGS. So for those who don't know the organisation, British Geological Survey, it's been working since in various forms since 1835 to map and understand the geology of the UK. And they produce the types of maps you may well have seen with the different colours representing the different rocks. And I've also grabbed the slice from Crew just to give a feeling for the detail. And this is all available on their website. And it will soon become obvious why this understanding of the rocks is so important. If we go on to the next slide. The first point, just I think to everybody to understand, is essentially why is it hot when you go down? Now, when we deal with shallow geothermal or ground source energy, that heat is for the main part the heat which comes from the sun. The ground is moderately warm and it cycles through the year due to the sun. But deep down, the heat isn't to do with the sun. It's heat coming up from the core of the earth. You probably all know, if you were paying attention in geography at school, the core of the earth is molten, That's what drives seismic activity and volcanoes and plate tectonics. And there is an enormous amount of heat, and it is in fact linked to the radioactive decay processes, which is why it continues on a basically indefinite basis. So that heat is there in the core of the Earth, and it's gradually passing up. And as you go down, it gets steadily hotter and hotter. The geology matters because it's not the same everywhere. It varies significantly as according to the types of rock. But as you go down a reasonable distance, you can get temperatures well over 50, up to hundreds of degrees in different places. I mentioned here that it basically conducts quite slowly, but of course, just by exception, it doesn't. If there's a volcanic eruption or places like Iceland, where there is the heat comes right to the surface. That doesn't apply in general in the UK. Bath, the Roman baths in Bath are the exception, really, more or less the best place in the UK for genuinely warm water that emerges just naturally. So if we can go on to the next slide, what this means in terms of accessing this heat is we have to take one of the routes to go down into the ground and recover that heat. And there are three possible sample solutions which are shown in the diagrams here. The first one to the left is the hot aquifer. So if you go down far enough into the ground, there's an aquifer is an area of rock which contains water. Water's percolated down through the ground and sitting in the aquifer. If it's far enough down, that water is genuinely hot. And in this situation, you can see there's a red pipe on the left where you extract hot water and you re-inject it down a cooler pipe, and that water stays in the well, in the aquifer, sorry. You don't want to take the water out because you end up with a steadily diminishing amount of water if you don't put it back in. The next diagram just to the right is a hot, what start as dry rocks. And this is the situation where you have to put water in and it works its way through to the hot well and you can pump it out again. So that's the second major solution. And a third possibility, which is interesting, but doesn't generally give the same capacity, is a closed well shown on the right as an example, where potential reuse of oil or gas wells, and you push water down or fluid down the well and bring it back up at a higher temperature. This is equivalent to those familiar with ground source heat pumps for a closed loop. And as you know, you tend to get less heat, but it's also can be quite reliable. We move on to the next slide. Those diagrams matter because they tell us what we need to look for when we're looking at the geology. Obviously, if you want to use the aquifer version, you've got to find an aquifer with hot water. And this diagram shows areas in the country where there is those types of aquifers. And so these make sense to look at to see if they might be applicable in the way that Kieran's described, and others will follow to talk about some more. Clearly, we're looking for situations where there's sufficient amount of hot water available and it's not too deep, and as Kieran says, it's linked to local demand. However, heat and hot water isn't the only solution. As we just mentioned on the previous slide, we're also interested in places with the hot rocks. If we go on to the next slide, and you would have noticed in the previous one that Cornwall didn't appear, and Cornwall features in this one because the granite that underpins most of Cornwall and some of Devon is an example of a good opportunity for hot rocks, and clearly these apply in other places. And this enables the solutions to be adopted in some other places. If we could go on to the next slide. So the purpose of today's seminar wasn't to obsess about geology, it's to point out the importance of it. It's the underpinning. You need to understand it to develop these schemes. But what we really wanted to make it clear is that there is heat down there, but its availability depends on the geology. So any study, as Rick will be about to tell us, has to start with that study and understanding of how that works. Really important part of this in geological terms is the extraction of heat depends on the permeability of the rock to water flow. If you can't have water moving through the rock or through the aquifer, then you won't be able to extract very much heat. It's a question of the ability of the water to come through and extract that heat. And similarly, if you're taking heat out, you need the heat that's coming up from the core of the Earth to replenish that. So you can only take heat at a certain rate. That rate's pretty high, but it's not infinite. You have to therefore to understand the rate at which that heat will come back up to do so. And a really important part of this is that where the geology is essentially the same, the performance of the system should be essentially the same. And the great benefit our friends on the continent have is they've got a lot of these schemes already. They can say that geology is like that, it worked, therefore this is very similar, it should work. And we need to get that same experience, carry lessons over from Europe and bring them here. And then as we develop more schemes, we'll be able to have confidence in the same way that they will be successful. Move on to my last one, please. So just a final word really from BGS, but we would definitely endorse these comments. Heat networks play a really important role in decarbonising heat and can support net zero commitments. And where the synergy comes is that that you need a heat network to take advantage of large scale sources of heat in general. What will soon become apparent is that whilst any deep geothermal scheme needs a reasonable amount of scale in terms of heat that it's being supplied to, and a heat network is the most obvious way to deliver that at really big scale, because there's definitely a large amount of demand on a big enough heat network. And as we're seeing more heat networks growing in the UK, through in part through our support from HDIP and GH&F, we see this is the ideal moment to engage with this, to see how deep geothermal can be integrated. That was my piece to introduce deep geothermal, and I'd like to pass on now to Rick to talk a little bit about how the projects really happen.
Super, thank you, Andrew, and good morning, everyone. I've been lined up quite nicely here. Yeah, our story really picks up very nicely from where, well, first of all, Kieran has instilled an interest and an excitement into the potential of geothermal energy. And then Andrew, on behalf of the BGS, has confirmed that you are in a hotspot. You're in a location to actually deliver some of that potential to the surface and begin your decarbonisation journey. Where GT come in really is at that point. We're a developer of geothermal projects, and we are already, as you heard earlier on, in the beginnings of that process. Given that Kieran's on this presentation, I felt it was only right and proper to include him in that header slide. But yeah, our job really is to turn some of that potential and bring it to life. That doesn't come without its challenges. Just listing a few of them. You know, we've been told there's a potential there. The BGS have identified at a basin-wide level that there's prospectivity there, but we don't know precisely where it is. We don't know the depth it is. That's important because depth correlates very closely with temperature. And quite often there's not been any drilling in that area in the past, and that's important because that's the means, as you just heard from Andrew, by which we turn that sort of idea into reality. You only know what's down there once you've actually been down there and looked at it through a delivering a project in the UK, as you've seen some of the earlier projects, quite often you're going to be up against schools, you're going to be close to council buildings, you're going to be in inhabited areas. That's the principle of a heat network. It needs to be close to where the demand is. So that it's vitally important that the regulatory and the construction permitting process is adhered to as closely. So you need to understand what the requirements are in order to move you through the project. You've then got to bring that heat to people's homes, into their businesses, into their places of work. So there needs to be a lot of integration from the well bore actually to the top sides and bring it across the surface infrastructure. And lastly, and not least, this is why I really talk about it with the final point on this slide, the commercial twist. This has got to work. It's got to work commercially for the consumer. There's no point bringing all this heat to the surface if it's done at a cost that is way in excess of what people can afford. And likewise, it needs to be done in a way that encourages the next project to happen and the next project. We're only going to grow an industry here if it works for everybody. So it's important throughout this workflow that I'm showing here on the slide that we do it in such a way that we're assessing and looking at the commercial realities of the project, as well as the technical ones. The workflow that we're showing here is actually very, very similar to one you'd follow for let's say a more conventional energy project, but it's important to have that commercial reality instilled from day one. Next slide, please. So that first slide, as I said right at the beginning, there is really picking up from where the BGS left you. They've identified that there's an opportunity there, but what we have to do by looking at our workflow is to start to put some parameters around that resource. We understand its depth and its temperature. We look at the complexity of the underlying rock to work out the best way to extract that. We need to understand from the surface perspective, where can we drill from? It's all well and good saying that there's a prospect 3,500 meters beneath your feet, but if you don't have a surface location that's large enough for the drilling rig to be installed, then that's no good for you. So it's marrying up the surface with the subsurface. We're very lucky in the UK. Over the last 50, even 100 years, there's been a very extensive conventional oil and gas exploration program. Lots of data exists carried out through first of all wildcat drilling, and then subsequently through 2D and even 3D seismic campaigns in various parts of the country. So we can access that, but we then need to be able to extrapolate from that and determine whether or not that's good enough, or whether or not we need then carry out a subsequent phase of data capture in the next phase in order to bring to life what's beneath our feet. Next slide, please. So as I said just a moment ago, one of the things that we might need to carry out during feasibility is a further data acquisition program. That quite often takes the form of a seismic survey. Seismic is pretty much like a sort of an ultrasound. For those of you who've seen one of those, it's carried out by bouncing sound waves into the earth and picking up the echoes as they come up. A little bit more differently, obviously, we're talking about hundreds and thousands of meters of rock rather than a few centimeters of skin, but the principle is very, very similar. And we need to then turn that data through a series of modeling processes into something that's real. Typically, we call that a 3D geological model, and that gives you a picture of not only the different layers of rock, but how they interact, whether there's any faults through that, and it's from that we build our understanding of what the costs are going to be when it comes to the drilling program, whether there's any associated delivery risks, delivery in terms of the drilling processes, risks in terms of seismicity from working in the wrong parts of the rock, and so on. So these are all things that we need to carry out at this early stage in order to understand not just that we've got a viable commercial thing, but actually whether it's feasible to deliver it and bring it to the surface. If I can then move on to the next slide, please. By this time we've got a commercially viable project. We need to then go and engage with all the stakeholders, both the regulatory ones, so that would be the councils and the Environment Agency, but also with the local people in the area, and understand whether or not there's concerns about how this project is going to be presented. There are engineering steps within this, and we typically refer to those as front-end engineering design, so early stage engineering works, and also the equivalent within the world space. But the important thing here is really trying to answer the questions that were flagged up during the earlier stages. And what we're now trying to do is put some meat on the bone and project out what the project is going to look like. That's will then help us to apply for the requisite regulations and permits from people. But it also starts to give us a better understanding of what the final costs of the project are going to look like, which brings us to the next slide. So within this stage of the work, we're starting to pull everything together. We've got an idea of what the well designs look like in order to deliver the project. We understand what the surface connectivity needs to look like in order to deliver that heat around the neighbourhood and bring it to people's doorsteps. We understand the costs. So we've gone out and we've tendered for the requisite services. We understand where the rigs are going to come in, and that's important to know because rigs are, first of all, in very short supply in the UK. We don't have an extensive history of drilling, certainly not in the last 20 years. And as a consequence of that, we need to bring in rigs from wherever they may be in Europe. So there's a long tendering process associated with that. You need to get the services, you need to get the materials. Those have all got to come to site in order to deliver the project. But it's got to, as I said right at the start, it's got to come and in such a way that it's financially viable for the end user. At the end of this stage, then, we've got a project that's good to go, technically, commercially, and everyone's ready to press the button. And at that stage, we then actually execute the drilling. This part of the project is going to be of the order of 12, 15, 18 months, probably of that order, no longer than that. We've got to go through all the planning conditions that were required for us, and then we also need to start the drilling process. In fact, if we can just jump onto the next slide, I can show here a picture a little bit blown up of a typical drilling site, and this is in fact Ralph's site in Pullack. I've used this by extension really just to give you an idea of some of the physical arrangements, and so the rig may be as much as 70 meters high and occupy something of the order of sort of 6,500 square meters of space. So a lot of that, and that's going to be in situ, as I say, for about 12 to 15 months whilst we drill and test the first and second wells. Once that's done, we go through the process of connecting it up to the heat network, and then at that point you have your local dignitary come along with the big shears and cut through the red ribbon. But of course, that's not the end of the story. Geothermal is long-term energy. There were projects purpose-built. The first purpose-built geothermal wells were drilled in the 1890s. But as you heard both Andrew and Kieran refer to, the geothermal wells in Bath have been operating for more than 2000. This is something that's going to be there forever. And it's vitally important, not only that you design it properly by answering all those questions that we highlighted earlier on, but then you operate that and you continue to work with it throughout the life cycle. And I'll come to the final slide, really just to highlight what things are sort of condensed down to. And here we've got the requisite picture of Kieran once again. But this in the context of where that large scale Pullack site has come back down to. It's all condensed to a building that's perhaps only 120 square meters. All of that governance may even be underground, as you're seeing there with Kieran. There was a reason for including that picture. It will periodically need to be accessed by the drilling company, but only on an intermittent basis. It could be used for car parks. Or as in the case of the Pullack site, as a laydown space for the construction of their district heating system. Last and final slide. So this workflow, it probably looks challenging, and I've rushed you through sort of the geothermal project delivery 101 in a few short minutes, but it's fundamentally a tried and tested one. This is a workflow that's been delivered for many years in other industries. It's one of identifying and mitigating the risks, resolving and then quantifying and reducing the uncertainties. And that way you end up with a project that's going to last you for the 100+ years that the geothermal potential can present. And at that point, I'll hand over to Ralph, as he can talk you through their experiences in Pullack a little better than I can, having walked the walk.
Hello to all of you from Pullack. First of all, I have to apologize for some slides not being very good. I had to reduce them in size to get them through to GemSurf, therefore they're a little bit pixelated. Next slide, please. Pullack is a small but independent city south of Munich with 9,000 inhabitants. It is mainly characterized by small houses, but also has about 550 units of social housing, beside public buildings like town halls, schools, an indoor swimming pool, convention center, retirement homes, but also commercial buildings, etc. Next slide. Talking about treasure here in Pullach refers primarily to the geothermal potential underneath Pullach, but you also may refer to the district heating network independent of the source behind it. A district heating network is expensive, but therefore a real asset, especially as it is hard for customers to change once they are connected. Next slide. In 2004, we started our business drilling 2 wells and laying out a district heating network. The drills were extended in 2011 by a 3rd well. This is Pullach and the existing district heating network. As you can see, all major roads are already connected. Our plant is situated in the tiny little green spot in the rightmost part in the red framed area. First, the community wanted us to build only a small network going up the Hans Kai Street, passing the community-owned social housing, the high school and the public swimming pool. So only everything that is within the red frame should be built. The reason was because all these buildings are run by the community. But doing so, the extension would have been at the end already in the 2nd year. Planning a network, don't think small, think big, as the diameter of the outgoing pipe from your energy source is the bottleneck. Marked in green are the connected properties with heat supply. Laying out a network for most of the customers, you come either too early or too late because they just have renovated their existing heating system or it is still in good condition. Not to lose these customers, we offer connecting options. Yellow marked are properties that have a connection from the main pipe into the property only. Blue marked are properties that have a connection from the main pipe into the house, but no heat exchanger installed. The fees customers have to pay, blue more than yellow, are credited against the costs for the final connection within 9 years. Next slide. Here you see the development of the construction sections over the years. What is important to note is that in all sections, the connection rate is rising every year, reaching a percentage of at least 50% or more of attainable kilowatts. Starting the network is best with big customers to get at the soonest the return of invest. Next slide, please. Here you can see the pipes of the district heating network, big pipes with fittings for the house connections, smaller pipes, and on the rightmost picture, a leakage indicator system that is integrated into the insulating foam, allowing us to detect the leakage almost accurate to 1 meter or 2. Next slide. Laying in the network, we simultaneously laid out a classifier cable to every single station. This allows to monitor the station and the heat consumption, important in cases of troubles, but also for automatic billing. This is a view onto a screen in our control room depicting the whole heat system of one station. Next slide. Depicted here is the connected load to the district heating network in total. In addition, every year in the line below, and the connected properties over the years. Next slide. This summing up in a connected heat load of 45 megawatts up to now and 1,340 properties corresponding to about 50% of all Pullach properties. During the normal development over the last years, we had about 40 to 60 properties connected each year. But what happened in 2022, marked by the red arrows? Russia attacked the Ukraine and the demand rose dramatically. At the moment, we are booked out already for the next 2 years. Next slide, please. Here are the main features of the plant and network specified. For redundancy, we have underground a 30,000 liter tank corresponding to 6,600 British gallons. If the geothermal plant isn't working on a peak day, how long do you think the content of the tank would last? 1 single day. The geothermal plant running well, therefore, saves a lot of fuel and emissions. Next slide, please. Displayed here are the expectations in our development over the next 10 years. Even here you see until 2031, we have something to do to reduce the use of fossil fuel for peak load and redundancy. But these were our plannings before the Ukraine crisis. Next slide, please. As I told you before, the Russian aggression against the Ukraine led to a tremendous increase in heat demand. Subsequently, we had to adopt our plannings. The need for new drillings became even more crucial. And that's what we want to do starting in 2025, drilling another 3 wells. Last slide. That's it. Thanks a lot for your attention.
Thanks, Ralph. We're now handing over to Gus from Eden Geothermal.
Thanks so much, Samantha. I think that my camera isn't working, so I'm afraid you can't see my lovely face.
We can see you, Gus.
Oh, can you?
You're okay. Yeah.
It's from this end. That's fine. So actually, Ralph's piece moves again beautifully onto mine, as my title is "The Energy that is Secure as the Rock Beneath Your Feet." In these difficult times, we really need secure energy that is based in the UK and not affected by geopolitical troubles, which seem to be more and more common across the world. Okay, so next slide, please. So this is our project. We have built a geothermal system. It's actually the first to come online in the UK for 37 years, and it produces enough heat for a rainforest. It's a slightly unusual project because it was funded by the EU as an industrial research project. So it had 2 aims, really. The first was to explore the geology in Cornwall and to go very deep to see whether it would be suitable to make an electricity system. And then because of the EU funding, we also had to produce greenhouse gas savings. So in fact, we put a coaxial system into that single well, and we are now running heat for the Eden project, some greenhouses that they put up for the nursery, and their buildings as well. Next slide, please. And why Cornwall and why the Eden project? This has also been covered a bit earlier in the project, but basically Cornwall has a spine of granite that runs down the county that is the source of Cornwall's great wealth and incredible scientific advances in the county. So the granite runs down in the spine. That's Dartmoor, Bodmin Moor, St Austell Moors and Cambrai, and then out to the Isles of Scilly. And here the granite is very hot. So rather than have a heat profile down into the ground of about 25 degrees a kilometre, we're as high as 37 or 38 degrees a kilometre. So it's obviously a good place to do geothermal. Next, please. And why the Eden project? Well, the Eden project is a very unusual place. This is it in 1995. It was a worked out China clay quarry. And you can see that it is a place of pretty much absolute devastation. So along came Tim Smith and decided to turn it into this. The Eden project, it's an environmental charity, an educational destination, and it had, before COVID, about 1 million visitors a year. It's also a big heat user. Heating a rainforest is not a trivial task. So it uses around about 4 gigawatt hours of heat a year, and also around 4 gigawatt hours of electricity. And we wanted, right from the very beginning, I've been working there at Sustainability at Eden for since 2001. We wanted right from the beginning to have our own renewable heat source and own renewable electricity source on site, so that we would be a proper sustainable project. However, our first effort was to try and put up a wind turbine, and the neighbours really didn't like that. So when we heard about geothermal, we thought this is absolutely the best thing. It has a very low public, a low environmental impact for the local population, and was very popular. So that again is a very key piece of information that I think people should know about, is that the absolutely most important thing is to start off by engaging your stakeholders, work out who they are. Is it your neighbours? Is it your internal stakeholders? And communicate and explain the benefits of geothermal as well as you possibly can. Our project actually has a bridleway that runs right past it. So when we started drilling, we put up a shelter and information for the public, but the engagement had actually begun many years before that. Next slide, please. So this is our project. We drilled it during COVID and Brexit, which was challenging. But this was the drilling rig. It's rather a little bit smaller than Rick's rig that he's expecting. It's a 55-metre tall, 450-ton hook load rig from a company in the Czech Republic. We tried to procure a UK rig, but unfortunately it wasn't possible. There aren't any in the country that are that big. We hope in the future that there will be some that big, but for very many heat projects, in fact, you probably won't need a rig this big. We possibly rigs no higher than 22 metres. This one was 55 metres. As you can see, it's also on a fairly small piece of land. It's about 1.8 hectares, but then a lot of it has got ancient woodland in it. So we had to leave the ancient woodland alone, and the actual piece of land is about a hectare that we used. The drilling was very slow and took a very long time. It took 6 months, 162 days, and that is also a function of the fact that we were drilling in granite. Projects in sedimentary basins would be much quicker than that. You know, maybe 3 months for a doublet system. These are some pictures of the well going up. It's the most the drill going up and people drilling away. As you can see, it's an absolutely fantastic piece of meccano. The drill arrived from the Czech Republic on 108 lorries. Again, that is a cause of worry for the local neighbours, but you just have to be experienced and understand that the logistics can be broken down so that the lorries are held somewhere else, and you just have 10 in a day, which is 1 an hour, and so that doesn't cause a problem at all. But logistics are really crucial around drilling. I think another thing that's important to say here is that we didn't have a combined services contract. I think it's a very good approach probably not to have a combined services contract. So you have separate contractors doing each of the services. It gives you, as a geothermal developer and a project developer, much more control about the drilling and the organisation than if you just have one contractor that does everything. So these are a few pictures. Oh, sorry, could we go back again? I just wanted to talk about a little bit about some of the challenges. So the gentleman in the middle looking at the drill pipe going down through the rig floor is our directional driller. So he was the guy who drilled down and managed to steer the well straight into our permeable structure down in 5 kilometers. He's called Billy the Kink. And the rest of the pictures are, yes, the rest of the pictures actually were done very largely by one of our neighbours, who started as one of the gentlemen who was not keen at all on the geothermal project, but eventually ended up giving his granddaughter cuttings for her Christmas present, poor child. Anyway, next slide, please. So this is what we did. This was our drilling program. It was a J-type well and was steered up to 40 degrees inclination into our permeable structure that runs a fault line that runs close to the Eden project. It's the longest geothermal well in the UK. That's not saying much because there aren't very many of them, but it is longer than the one down the road at United Downs that Eloise is going to talk about a bit in a while. The drilling process, I think it's fair to say, is fantastically well understood. Thousands and thousands and thousands of oil wells have been drilled all over the world, and this is very, very much the same technology. I think it's an important message for people to understand that although geothermal is a new technology for this country, the technologies and the skills that come across from oil and gas mean that actually the drilling part is probably the least technically challenging bit of it, although the challenges are very well understood by the drilling community, and it is important, however, to have some geothermal expertise in your oil and gas mix so that you understand the differences as well as the similarities with the drilling program. So we had, I think it was 26 subcontractors, 26, one main contractor, 26 subcontractors, and all but 2 of them were oil and gas companies, and that again, it's an interesting challenge. Oil and gas are used to drilling very many wells. They're not used to drilling one well far away in a remote part of the UK. And I think it will be an interesting part of the development of the industry to find out how perhaps better geothermal developers can work with the oil industry. There's certain issues around contracts and things like that and risk sharing that it would be very, very helpful for the government to get to grips with. Next slide, please. So at the moment, we have a coaxial system. This was a feature of the way the project was funded. It was a European funded project, and they required greenhouse gas savings from our single well, which was the maximum amount of money we could get from them. So what we have is one well that goes down 5,277 meters, and it's cased to about 4 kilometers. We then have a vacuum insulated tube inserted inside that well and an electrical submersible pump at about 300 meters. That electrical submersible pump sucks the hot water up from about 4 kilometers and puts it through a heat exchanger and sends it down to Eden, its biomes and its nurseries. Next slide, please. So this is the route of the heat main. I'm sorry, we haven't managed to knit together a picture of the final system yet. You can see the geothermal plant at the bottom left of the picture, and it runs down our road past the new nursery that Eden has put up for us in order to help use more of the heat, and down to the rainforest biome. It's a 6-inch pipe with polyurethane insulation, and the anticipated temperature loss is less than 1 degree C. We've actually been commissioning now since about July, and last week we started heating the rainforest and the nursery in earnest, because until now, because of the climate, they haven't actually needed any heat, but now the heat is on and it's all working pretty well. But it probably take us a while to learn how to run the heat to its full optimization, and we're looking for other businesses that will be able to co-locate on our site. Next slide. And it really is the smallest final surface footprint of any energy source. Here is the drill rig as it was in place, and then the next picture is what was left. And in fact, even that is over-egging the pudding, because the large green steel structure is gone and one of the small black container is gone. So we are left with literally a wellhead, a 20-foot container and a 40-foot container. The 20-foot container contains the pump control, which is a Schlumberger pump. They have redundancy. We have spares that are kept up with Schlumberger up in Scotland. And then the heat exchanger is in the 40-foot container, and the heat main runs down that road down towards Eden. Next slide, please. This is just to reiterate the advantages of geothermal energy. It is baseload, and that is absolutely golden. And across Europe, it is cheap. It's not cheap yet in the UK, but we hope very shortly it will be. The more you do it, the cheaper it will get, as you understand the structures that you will go into, and it is as secure as the ground beneath your feet. I think it's really important that the retrofit is emphasised. Paris has over 50 projects, including Orly Airport, and the fact that Orly Airport is the most critical infrastructure that you can imagine just shows that it is possible to put in geothermal almost anywhere. The scale, and to scale up fast, we can use the skills and equipment from the oil and gas industry with a bit of geothermal expertise, and the impacts are really, really low. One study has said there's a 93% saving lifetime emissions reduction on gas heating, and that's including all the piping. And there is, importantly, for urban developments, there's zero emissions and particulates in operation. Next, and this is the last slide. It's just to make the point that about a third of constituencies have geothermal prospects, half local authorities, and 100+ NHS hospitals have also got geothermal prospects. This has been studied by BGS, and we really think that geothermal should be able to take its place, no longer be a sleeping giant, and take its place alongside other renewable technologies to do the best for decarbonising the UK as fast as we possibly can. Thank you.
Thanks, Gus. We're handing over to Eloise now.
Thank you. Morning, everybody. I'm Eloise Travis. I'm from Treveth Holdings down in Cornwall. We are a Cornwall Council-owned business set up to deliver sustainable and affordable homes for people who live and work in Cornwall. And we're also master developers for the Langarth Garden Village project. Next slide, please. So just to give you a quick overview of the Langarth Garden Village project. This is a Cornwall Council-led development on the western side of Truro. It aims to improve the quality of house building in the southwest, and we have outline planning permission for 3,800 homes, primary schools, and the usual sort of mix of green space, community facilities, etc. But we are also proposing to have the UK's first deep geothermal heat network serving residential properties. Next slide, please. So bit of a repeat of what others have said, but we know that Cornwall has some of, or the highest deep geothermal potential in the UK, and because of that, Cornwall Council have invested quite a significant amount of money through ERDF funding and through match funding into the United Downs and Eden geothermal projects. In the past, the industry has struggled to get funding and investment because of the risks, and so Cornwall Council were able to step in and try to help unlock that industry. And that has led to the development of the United Downs and Eden geothermal projects. In the meantime, Cornwall Council and Langarth Garden Village have then been developing the Deep Geothermal Heat Network project for Langarth over the last few years. We've gone through 2 rounds of feasibility studies, and despite a lot of people thinking that we wouldn't find that it was viable, it certainly is so far proving to be viable, and we further increased confidence in that via a recent Green Heat Network Fund award of £22 million to commercialise and construct the heat network. So we're very much still in the commercialisation phase at the moment, fairly early in that commercialisation phase, but the project is moving forward. Next slide, please. So just to give you a bit of background on the Geothermal Engineering Limited United Downs project. So Geothermal Engineering were established in 2008, and they have probably been developing the project at United Downs since shortly after that time. So they will be the developer and operator of the first deep geothermal power plant in the UK. So like Eden, they have successfully drilled their wells. They actually have a doublet well. So they have drilled a production well of 5,275 metres down into the Porthtowan fault zone, and they will be drawing up geothermal brine, which, and testing so far has confirmed that the temperatures at the bottom are around about 175 degrees, so about what we'd expect to find in this part of the country, and sufficient for power production. So they have recently ordered from Exergy International an organic Rankine cycle power plant, which will look a lot like the picture in the top left hand corner, and that can produce gross power of around about 3 megawatts. Next slide, please. So in terms of that power plant, groundworks are due to start this month. Exergy will be on site early next year, and we're expecting the power plant to start generating before the end of next year. So really exciting to see this now moving forward at pace. We have, as I said, undertaken 2 rounds of feasibility study, and on the basis of what we know prior to that power plant being designed and starting to operate, we've been working on the basis that 10 megawatts of heat would be available at 80 degrees C. Now, I know probably quite a few people on the call are interested in how we're going to take the heat from that power plant. It's very much still a work in progress. We are literally at the moment involved in negotiations with geothermal engineering, assessing how that heat will be captured. It's likely to either be taking heat from a point within the power plant where we're not compromising power, but that may require some additional generation to upgrade that temperature, or we may decide that the best option is actually to compromise some of that power to maximise the heat. So like I said, very much still a work in progress. But something that hasn't been mentioned, and it is something that GEL in particular are able to harness, is that by bringing up the geothermal brines, they have confirmed that there's more than 250 milligrams per litre of lithium in that brine, which so they're proposing effectively 3 strands to their business to power the heat and the lithium extraction. So it's a really fantastic opportunity for us here in Cornwall. Next slide, please. So as I mentioned, we're in the commercialisation phase at the moment. We are currently working through that, assessing the needs of potential customers. We have the 3,800 homes and some businesses that will be developed at Langarth Garden Village that we're expecting all of those to connect, and we'll have Section 106 agreements in place with the developers to ensure that they do connect to the heat network. But Royal Cornwall Hospital adjacent is a really important anchor load. Like other hospitals, they have quite challenging decarbonisation targets. So we're in a really lucky position to be able to work with them and help them to meet those targets. But we also have, the area around Langarth is already quite well developed. So there's a secondary school, a college, health worker accommodation, and other businesses that we're expecting to connect. So we actually have a peak load of around about 14.5 megawatts that we're expecting to serve, and about 47 gigawatt hours of annual demand. So it will be quite a significant heat network built out over around about 25 years and is in the region of a £90 million capital project. We're also proposing to provide a full backup supply as well, and we will be seeking a delivery partner to operate via a concession agreement hopefully from next spring. Next slide, please. So in terms of getting the heat to Langarth, although some of the other presenters have talked about the need for the deep geothermal well to be close to residential areas, actually, although this doesn't look very far on the map, the distance between United Downs and Langarth Garden Village as the crow flies is 5 kilometres. The area in between the two is extremely challenging. This is a heavily mined area, although we do have maps of former mines and adits and open workings. There are a lot that are unmapped, and it's also part of the Devon and Cornwall Mining World Heritage Site. So although the landscape is already heavily mined and heavily disturbed, we cannot cause any further disturbance to that land, it has to be left in the condition it is. So that means that our heat main will actually be around about 6.5 kilometres. So this is one of the biggest challenges and one of the biggest risks for this project, is getting that heat up to Langgarth Garden Village. So we're currently working through trying to de-risk this, looking at the ecology, existing services. There's a main rail line to cross, the mine workings I mentioned, also a lot of listed buildings, and around 20 landowners. So we're starting negotiations with those landowners. They're going really well, actually. This is a really sort of positive project for the community. Opportunities potentially for further connections along that route as well. So we're hoping that within the next sort of 6 months or so that we can progress to a planning application and help to de-risk this part of the project. Next slide, please. So in terms of the benefits of the heat network, certainly our base case of 10 megawatts of heat at 80 degrees, we know that for the counterfactual argument of an air source heat pump for each home, we can save over 86,000 tonnes of carbon with this project over its lifetime, so around about 40 years. So that's quite a significant saving over what would otherwise be considered a low carbon technology. And we're also currently expecting 25 to 30% cheaper heat for the new homes at Langgarth Garden Village. So there's some real significant benefits to bringing this heat up into Truro, and not least, of course, creating more local jobs, apprenticeships, and helping to develop an industry. Next slide, please. So as I mentioned, we're working through the commercialisation phase at the moment. We're looking to complete that hopefully by next spring, all being well, and then we'll be looking to tender for that concessionaire, and we'll probably be going out to having some sort of pre-tender discussions and soft market testing of that. So something to look out for if that's of interest to you. We're hoping then within about 12 months from now to appoint a delivery partner. The first homes at Langgarth Garden Village are expected to be completed in spring 25, so they'll require a temporary heat supply, but then eventually that will be connected to the deep geothermal heat, hopefully around 2026-27, at the same time as Royal Cornwall Hospital. I think we've got one more slide, and that was it. Thank you. So it's quite a whistle-stop tour. It's a huge project, a lot of work going on in the background and working with the partners here on the screen, but it is all progressing, and hopefully we'll be able to give a bit more detail within the sort of next 6 to 12 months on how we're going with this and how we're going to extract that heat. So thank you.
Thanks so much. We look forward to receiving more updates as things progress. So we're now moving on to our Q&A. We've had quite a few questions come through, and I'm going to start with the one with the most likes. So Gus, it was one for you actually. How did your original expectations at design stage turn out post-testing in terms of temperatures, flows, thermal outputs and costs? Was it as you had expected?
We have some complicated geology, so the temperatures were absolutely bang on. It's very close to 200 degrees down at the bottom of the system, but we have some complicated geology. When we hit, we were just about to case off our 12.25 inch section. We hit a very, very large void indeed, and lost an awful lot of drilling mud down it, and we had to cement that void closed, and that system seems to be dominating our well, which is it's a complicating factor to decide whether we will go ahead and do a second well. We also have a complicating factor in that our grid connection offer is for 2036, which makes life extremely complicated from a business point of view. I think, as Rick very clearly pointed out, there are an awful lot of complicating factors to producing geothermal systems. So yes and no, it is permeable, but it is complicated.
Great, thank you. And Ralph, one for you, please. Have you observed any temperature degradation over time as part of your network?
No, the opposite is the case. The temperature is still rising. So one well has 103 degrees and the other one 107 at the beginning. TH1 has now 104 and the other one has 108. So the temperature is still rising. And also the productivity is going up. Fantastic,
thank you.
Yeah.
Question for the panel, be good to know who'd be wanting to take this one. Who takes the risk in terms of the borehole if it doesn't produce what's being asked of it? For example, if there was lower hydraulic flow or the temperatures weren't quite as expected.
I'll jump in on from a GT position, but I guess yeah, as the BBC would have you know, other positions are available. So one of the reasons, not the only reason, but one of the reasons for that extensive workflow is to de-risk the project. So our viewpoint is that we will take delivery risk. So exactly the case that you've just identified there. If we don't produce the temperatures that are have been agreed to, or we don't discover the hydraulic flow, yeah, that's something that we as the developer will swallow the costs on. The whole point of the workflow, as I said, is actually to fundamentally assure ourselves before we get to that commercial position that the project will go forward. Yeah, fundamentally, that's no real difference to the way an oil and gas company works. If you think about it, you know, they'll incur all the costs for drilling and developing, and then they sell on into a liquid market. So we don't have any problem with doing that. But as I say, I know that there are other positions out there.
I think it's fair to say that one of the things that the industry very much wants is for the government to step in and have some kind of risk sharing financing in order to get the industry off the ground. We respect Rick's position very, very much, but actually when you look at how other countries have developed their industries, certainly in France and in Germany and in Turkey, and the Netherlands, it's very, very common for the government to take some kind of risk insurance. Of course, at the moment, we're in the situation that geothermal is in a bit of a black hole in legislative terms, and we're very, very grateful for Kieran to be pushing the all-party parliamentary group, and hopefully we'll get some legislation through soon that kind of recognises geothermal in law, and also helps with regulations and possibly even contributes to risk management in geothermal risk.
Thank you both. There were a few. Oh, go on, Rick.
Yeah, I was going to say add one thing, which is I guess not company specific, but look at industry, in the industry as a whole. Geothermal for heat, and I emphasise that, as opposed to for power, inherently is the project success rate is very much high. Yes, there will be instances where, for instance, the hydraulic flow isn't perhaps as high as you'd hoped for, but there will still be some flow. Similarly, temperatures are, it's a given that as you go deeper, you will deliver more and more heat and temperature. So when we think about risk on projects, we mustn't fall into the mindset that it's a binary thing. It either succeeds or it doesn't. It may not deliver precisely as much as you'd hoped for, but you might get 90% of the heat flow, you might get 80%. So that needs to be factored, and that's fundamentally from a commercial standpoint why we feel able to take the position we do. And I would totally agree with Gus that I think a broader view of risk in the delivery of heat to the surface is absolutely welcome.
Thanks, Rick. in terms of setting up or considering geothermal heat, is there a benchmark for the minimum level of heat demand that you might want to look for to make geothermal an economic option in comparison to others? Could be a question for you again, Rick.
I'm going to prevaricate, I'm afraid. It really does depend on where you are in the country, and just why is that the case? It's a function of depth, and that becomes temperature, as you've heard me and others say many times. So the deeper you have to drill, obviously that costs money. So you've got a balance between capex and e-flow, but depending on the amount of flow rate that you expect to deliver from that particular location, will also have. So it's very, very unique, and that's why I talked about the commercial dimension being absolutely inextricably linked all the way through the workflow. You don't want to be getting to a point where you suddenly discover that it's sub-economic, having invested, potentially years of time and millions of pounds of money to get to that point.
I think it's also worth saying that there may be options underneath very many sites, particularly in sedimentary basins. So you might have more than one target beneath your site. So you can either drill more shallowly, which is cheaper and quicker, and then have a heat pump on the top, which might help, or you drill deeper and go hotter, and that is a kind of calculation which is always very, very site specific. But I think that it's worth making the point that augmented heat pumps have a very much higher COP if the inlet temperature is higher than the usual for ground source heat pumps. So that if you're looking at only having to raise the temperature for a district heating main of 10 or 20 degrees rather than 40 or 50 degrees, you're doing very well from a COP point of view.
Okay, thank you both. Eloise, a question for you. What advice would you give to somebody looking to embark on their geothermal journey, given what you know now and the position that you're in?
I think allow a lot of time, and then probably allow a lot more time on top of it. Everything takes a lot longer than you think. There's a lot of challenges to consider in terms, particularly in terms of getting the heat to your customers effectively. That I think the timescales for that are considerably longer than we perhaps at first considered. So I think just time is one of the key things for me.
Thank you. Does anyone else want to add any other wisdom?
First thing I want to say, because I didn't mention in my presentation, is that a lot of what we understand about the resource is based on where we have the data. So actually there probably are even more places that we could do it. So don't kind of superficially rule yourself out based on one particular map. I think it's always worth exploring. So for example, that one system I use to pick locations, another slightly different system might pick up a few more. So look far and wide for deciding whether you should do it. And then the other point is, I think the reason why we're so keen for so many more people to start doing it is I think a lot of these challenges will become lesser if there's a bigger industry in the country overall. So I think that's that. I don't want people to. You've heard a lot of the challenges today, and they're absolutely there, but they're there to a higher degree because these are the people on the leading edge of this. And actually, as more people do it, it gets easier and easier. And I think that's the experience from Europe, really, that once you've got a wealth of expertise and companies and people who've experienced in doing it, it should all get a little bit easier. So don't be put off by the fact these people that you're talking to today are really kind of pioneering it in this country, and so are bound to face a greater degree of challenge.
I'd just echo Kieran's point there. I mean, you can get a fixed price contract for drilling a well in Paris. I'd love to be in that position here, but I think it'll be a few projects down the road, but we will get there.
Great, thank you everybody. I'm going to hand over to Andrew now, just to close our the webinar today, we know there's a few more questions that we haven't got around to, so we'll review those and hopefully get back to you all in the near future. Andrew, just over to you.
Thanks, Sam. So that was, I hope you all agree, extremely useful. It falls to me first, of course, to thank all of our speakers for their extremely valuable insight and information. I think what we've learned is that clearly there is great potential to deliver geothermal systems in the UK, and we're beginning to see these projects coming through, which is super exciting. But we should put that in context to say we can learn from Ralph and many colleagues across Europe who have very many more of these schemes, and we don't need to say, oh, it's difficult, it can't be done, there isn't much experience, because there really is a lot of experience, and we must take advantage of that and think about this in the most positive way. Now, the questions have raised some of the concerns. Obviously, drilling these wells is expensive, and I think optimizing that with getting the right interactions with the potential customers, and as that discussion was going on there with Rick and Gus about the amount of heat and the amount of what makes it viable, I think we're going to need to work on that collectively and find really good integration with significant heat loads and heat networks. But I think this is a really important time as the heat networks that we're building are growing, and we need, as we've just heard from Eloise, how important it is to start thinking early and get the wheels turning, because these things do take a long time. And I think from that point of view, we would love to hear from more people. If you think you might be able to come through to GHNF, come and talk to us about that route. But I'd also like particularly to thank Kieran for both his input and his previous work, and also his very generous offer to engage and help push these things along, because one of the things we've learned across GHNF is the importance of getting buy-in at all levels, and a question commented on local authorities and the very critical role that local authorities so often have in helping to make all these actions happen. And it's so much easier when there's broad buy-in, the stakeholders that Gus mentioned as a central part of making these schemes a success. We need to bring everybody with us and convince them that this is the right solution to do. It's easy to say we must have money, we must have this and that. I think it's really valuable to push for those, but also to take the opportunities to drive projects along and show how to be done. So with that, and mindful of not wanting to overrun, I would once again like to thank all the attendees for their good, interesting questions. And as Sam says, we'll try to respond to a few more of them. And a final thank you, thank you to my the team at GEMSA for setting up the event, and for the panel for such valuable presentations. And I think with that, and noting the links on the screen that you can come to for further information, should you wish, if you haven't already found us, I wish you a good morning and hope that everybody found this helpful. Thanks very much. See you all again soon.
Thank you.